Hello, I would like to welcome you to this new video on NumPy. In my previous videos, I introduced a crash course on Python. Today, I will be talking about NumPy. And NumPy is a linear algebra library that is being used in Python. It is very important for data science as it's the backbone of all the building blocks within data science, because you will find that all data science packages that have been implemented, they are all utilizing NumPy. Therefore, NumPy is an integrated thing that you cannot avoid not to actually learn and not to be able to use. Therefore, today I will talk about NumPy. I will record maybe 2 or 3 videos to try and cover the basic principles of how we actually utilize NumPy. But NumPy does not come in most cases pre-installed in your environment. Therefore, you will need to install it. And to do that, you will need to go into your environment, as I'm doing here, and you need to go and select Anaconda prompt, and you will use a simple pip install or conda install NumPy. So as I was saying, it's just simple pip install NumPy. And if you hit the return, then it should start installing NumPy. So it's simple to install, it's not difficult, and it should start. So now I have started the installation. It should tell me that requirement already satisfied, because I already have the latest NumPy version on my system. Okay, to use a NumPy, you will need to import it into your Jupyter notebook. And to import it, you actually go and import NumPy, as you see. So we use the keyword import followed by NumPy, and then we say as MP, because whenever I want to use, or whenever you will come to use NumPy, you don't want to always write NumPy. So we say import it as MP, which is MP is a short name for NumPy. Therefore, when I come to use NumPy, let's say a function like arrays, I will say np dot, and I will call the function which I need to use or utilize. Therefore, it's very simple, and you will get used to this notation as you go on. Again, you will have to run this to actually go further. Now, what are the key features of NumPy? Now, NumPy has a number of key features. It's actually powerful, and it's one of those packages that are objects. It allows you to use objects as arrays. It actually, how shall I say, it works with any array dimension, and it's particularly useful when representing matrices and tensors, and I will explain tensors as and when I start using them. This is a different type of or a faster way of actually calculating arrays. It actually includes a wide range of mathematical functions. So mathematical function is something that is very, very important when we are coming to utilize NumPy. It actually operates on entire arrays of data without the need to explicitly, use loops or anything like that, because it's a package that's already included there for you. it provides a rich set of linear algebra operations, because you don't want to every linear algebra operation you want to actually utilize, you don't want to go and program that. So there is this is available within the package itself for you. There is other things that we will actually get to see as and when we start using NumPy. So let's see, the first thing is actually creating an array from a list. Now in the previous videos you've seen that we managed to create list, which is actually just square brackets, and we enter some values in there and we separate them by commas, and that will become your list if you assign it to some variable. And in this case I am actually assigning the list to an array underscore list, and then I will actually use NumPy array function. Now it will take this list and it will convert it to a one-dimensional array. So whenever you actually see that, it will not be seen as a list, it will be seen as an array, which means it will actually include it, and it will remove the commas between it. So it will be space separated rather than comma separated, and it will be looked at by the compiler, the Python compiler, as an array. So if I run this, it should actually unprint it, then it should actually show me the array without these commas here. Now if I want to create a two-dimensional array from a list, then I need to create a two-dimensional list, and we've already seen how to create two-dimensional list in my previous lectures. If you haven't seen it, please go back, watch it, and then learn how we create two-dimensional or nested list, as we called them before also. And then I use again the function array to convert this two-dimensional list into a two-dimensional array. So it's very simple. I just called a function from the library. That's why I said it's very powerful, it's very important, and it's an easy way to actually create arrays from lists or from data that you already have, because you will be having data, you will upload data which might come in the form of a list, then you can convert it into arrays, and later on in this video I will show you how we will do that. Okay, so let's run this cell, this simple cell, and you can see in the first line it's actually executed the result of executing this command here, which is actually creating the one-dimensional array, and as you can see it displays exactly that list, but now in the form of an array, a one-dimensional array. And this two-dimensional array is the result of this print statement here, which actually just display the execution of this conversion operator, where I use this function again, which is the array function in the NumPy library, to read this nested list or two-dimensional list, and it will convert it to a two-dimensional array, as you can see. So can you see this bracket here and this one are actually enclosing the array, and this is the first row and this is the second row of my array. So it's actually a 3x2 array, as you can see. Now we can also create arrays with a range, and we've seen the function range before in some previous videos when I actually introduced Python. Now, as we did with lists, where we can create lists using a range, we can do exactly the same. And in here, what do? I actually include the start, the stop or the limit, and then the step. So I will be taking a step of 2 rather than a 1. If I wanted to actually change that to go from 0 to 9, then I will actually put 1 here and it should actually create that. So if I run that, can you see it actually goes to 8. If I actually go and include say 1, then it actually goes from 0 to 9. So you can create any array of any shape as long as you decide on the logic of that. So you can actually say 3 and then it will take a step of 3. So it produces a different array and so on. So please try and practice, because I said this should be a hand-on coding course where you can actually see what I am doing here and you try and follow the same example and then try and extend it by changing and playing around with the code that you are provided. And by the way, you should be able to download this Jupyter notebook from the actual YouTube channel, so you don't have to type everything. But please, as you are watching, try and open the Jupyter notebook and try to follow the code yourself. Now, the next thing I want to do is just creating an array of zeros, because when we start building machine learning algorithms, you will see that you will need arrays of either all ones or all zeros, or you might need an identity matrix so you can actually carry out some mathematical operations. Then you need to create these matrices, and rather than actually code them by hand, it's easier to create them, because we know how to create by calling these functions. So I am actually calling this function and I am defining the dimensionality of the array that I want. In this case, it's a 3 by 4 array. I can change it to 3 by 3 or 3 by 4 or 4 by 4. So it's up to me. So you play with these numbers here and you create different dimensional arrays. It's up to you. So in the first one, I am calling the function zeros, and this way I will create an array which contains all zeros. Or in the second one, I am actually calling a function ones, and it will create an array which actually contain all ones. So it's very simple. So if I run this, you will see I have created a 3 by 4 array of zeros, and I created a 2 by 2 array of ones as a result of actually executing this function and then followed by this function. Now you can change this to make it 4 by 4, and it should actually change the shape of the array, and you can make this into 3 by 6, and then run it, and you can see that I have changed the shape of the array. Or I can make this 4 by 6, or I can make it 6 by 6, and you can see now I am actually able to create all these different arrays which are suitable for us to utilize in our coding, because mathematical operation will require us to actually have something like this. Creating identity matrix. Identity matrix, as you know, is very, very important in algebra, and you need to be able to understand how you create this identity matrix. And we are not going into the mathematics of how we are actually going to utilize this matrix, because you should have learned all this in your calculus, in your linear algebra, and so on. Therefore, you will need to be able to go back and brush up on your mathematics. This is not a mathematics course. You need to actually understand what a one-dimensional matrix is and how we utilize this in mathematical operations. If you are interested in a course which is on linear algebra or calculus for machine learning, please let me know in the comments, and I will actually go and create a video, a basic video introducing the basic principles of whatever subject that you don't have background in. You just have to mention it in your messages. It's very important for me. So now we are calling the function I, and this function I will create an identity matrix, and in this case I am defining is 3 by 3. I can change that to 4 by 4 or 5 by 5, whatever dimensionality I want. So as you can see, it's so simple to actually execute these functions and to call them. All I'm doing is just saying I want to use the package NumPy, which is NumPy, and then I will call the function by saying dot the name of the function, and within that function then I will pass the variable that I am trying to do. In this case I want to create a 3 by 3. In the previous code I wanted to create 6 by 6, and I will pass both of them, or 4 by 4, and here I just pass one parameter 3 by 3, and now if I run this you can see it actually creates it for me, which is a very convenient way. If I change this, it actually gives me 4 by 4. If I change this to 7, it should give me 7 by 7, and I can actually create any array that I am interested in. So arrays are going to be an essential component in everything we do, because later on you will see that if I am actually coding or trying to use a neural network to optimize an algorithm or a model, say let's say a neural network model or a deep learning model, I need weights, and I need to start with some how shall I say, with some startup random weights. Therefore I can create an array of weights which is random, so I can say I want them random between this and this. I give the range of 0 and 1, and then it goes and create that for me. So it's very important to understand. So how do we create a random array? It's very easy. There is a function called random, which is within NumPy. I will call that, and then I will call rand, which actually goes and it's a method for creating arrays of random numbers between the range that you actually specify. So, and I pass in here the dimension of the array, which is 2 by 3, because I want to create a 2 by 3 array, and it will be between the range, this rand of 0 and 1. So it will give me a new array that the cells within the array is actually between 0 and 1, but they are random. So if I run this now, can you see the values here from my original run is 0.26, 0.64, 0.255, 55, 0.89, 0.27. Now when I run this, it should give me different values. So look at this, it's random. 65, 61, 56, 70, 70, 5703 here, and 929. So if I run it again, it should actually give me different values again. Why? Because this is random. This is the meaning of randomness here. It actually gives me random values in these cells every time I run it. And that's the beauty of creating these arrays. And it's, as you can see, it's actually automated. So I can change this now, and I want it 3 by 3, and you can see now I can create a 3 by 3. Or I can say 9 by 9. If I want a larger array, then I can actually go and create a 9 by 9 array. And if I want to make it 6 by 6, then it actually 6 by 6, or 2 by 6, or 3 by 6, or 1 by 6. Whatever I want, I can actually create it, and it should give me the result nicely. And here we are displaying the result. Now later on we will create this array, and we will assign it to something else where we can utilize that something else in our code, and we will see many examples of that later on. We can also create arrays using range, and you remember we already seen how to use range in loops, or in creating lists or dictionaries, or strings and so on. Therefore, it's simple. I am just repeating stuff that we have already explained in our basic crash course on Python. That's why it's very important for you to go and watch that video and come back here. It makes this introduction of NumPy even much easier for you, because you have already seen most of these functions and how we use them. So I am actually passing the range function the range of the numbers that range is going to automatically create for us. Okay, and I want to create a one-dimensional array. Therefore, I am actually using array, and I didn't say the dimension of that array, and I just passed to it the range. Using the range function, and I will pass to that the maximum range is going to reach. Therefore, it will go and create that array for me from 1 to 5. Now, I can also create with specific data. I need to say I want the data to be created. I will give it starting point. I will give it the maximum where it will stop, and I will give it the step. And this step I showed you before. It can be 1, it can be 2, it can be 3, it can be whatever you want. And if you run this, then we should have the actual array created for us automatically. So let's say I will first start by saying this is 1, and you will see that it actually gives me from 2 to 9. If I put this back to 2, it will actually use a step of 2, and it should give me only 2, 4, 6, 8, all these even numbers within this range. So I can create whatever I want using these methods. And this is using range. Now I want to use arrange, the function arrange, and again I will specify starting point, limit, stopping limits, and step, and it should actually give me the same result, which I have actually created in the first using range. So arrange will give me the same as the range here, which we have seen earlier. So let's see, run this, and it actually gives me that. So if I change this into 1, it should actually give me the one-dimensional with the full range between 0 and 9. So it's up to you how you want to play this, and please practice, practice, practice. That's very important. We're actually going to format our arrays by using line space. Okay, a function called line space, which is a function in NumPy that's used to create an array of evenly spaced values, i.e. they have to be decided on the space that I'm actually going to use. So if I say I am actually starting at 1, at 0, then it's actually 1, and the number is 10. That means I have to split this between 0 and 1, and I'm going to use 10 numbers to represent the values between 0 and 1. Therefore, it will start with 0, then 0.1, 0.2, 0.3, 0.4, all the way to 1. And this is a nice way of actually splitting or creating the array with a specific number of content, because we can change that to anything we want. So what we are doing In here again, I am using the line space function, and I can actually then go and call that from NumPy, which is the package we are using, the library. I'm not sure, do we have this in help, NumPy? Can you see there is a NumPy reference here in the help? Because I'm only given limited information in my course here, because this is part of an introduction into NumPy. Now, if you want more details on NumPy, then please go to this documentation reference, and it will give you more detailed explanation about the use of NumPy, the libraries that are available on NumPy. But please, before you go there, go through the course. Then for further information, go to this reference, because once you take the basic principle from this course, then if you go to the documentation for NumPy, you will be able to understand what's happening easier and faster. Therefore, please go through the course before you go to this help. I am mentioning the help because this will take you a step further, which at most times you come to do something in your professional life, and you want to see if there is a library or a function that can actually help you to do the logic that you are trying to execute in creating a NumPy function. Therefore, you go there and you try and see if there is a function. They will actually explain the working of that function, and they will give you example of how you utilize it. For example, can you see here what we have actually mentioned? These three parameters which are used in this function arrange. In there, they will tell you what the 0 stand for, what the 10 stand for, what the 2 stand for, and so on. These functions here also, we have actually passed two parameters. They will explain to you what are these parameters and why and how you can use them and what are the limits. In here, it will tell you what this 7 mean and so on. Therefore, it's very important for you to actually go and understand how these things are used. If you forget, you know that there is a reference document provided, so you can go to that reference document and you can try and understand what's actually happening. Okay, let's continue with what we are doing. So we are using this a range. So if you run this, you get this. We actually went and talked about line space and the function line space. Again, as you can see, this line is actually taken from a document. Just to explain, this is start point, stop point, and the number is 50, which means you can actually specify the end point that you want to stop at. You want to understand the actual numbers that you want to include, and this way you will actually know, depending on what you are trying to create, what to put on these values. So let's look at how we actually use it. I am going to use line space, and I'm going to start with 0, and we are going to stop at 1. So I am actually creating these values between 0 and 1, and I want to use 10 for space. Now I can actually increase this. I can say I want 50. Okay, now if I run this, I should have a different array, which actually given me values between 0 and 1. It's given me 50 values in this array between 0 and 1, each equally spaced. Okay, so this is how it's actually done. So you can see this location here is actually half the location here, and this is actually 3 times, this is 4 times, and so on until we reach 1. So it's actually 50 equal entities in that array. Okay, so if I bring this to 10 to make it, or to 5 to make it fit in one line, so you can actually see it, it's actually done. It's given me 0, 0.25, 0.5, 0.75, and 1. And that's a nice way of creating a matrix. Okay, so identity matrix. Now we are going to create two-dimensional identity matrix, and I showed how we actually used the I function earlier to create this function, and I've just repeated here the actual use, and I also included some explanation for you to understand what we are doing. So in here I'm saying that function is used to create two-dimensional identity matrix, which is a square matrix with 1 in the main diagonal and 0 elsewhere. So I'm defining what this identity matrix is. If you go and study the background mathematics, you will know why we need this identity matrix, because it's very important when you're trying to let's say, for example, calculate the inverse of a matrix, because we want to do some operations where we need the inverse in multiplication cases mainly. Then you will see that identity matrix is an essential part that you need to calculate to be able to do that. The identity matrix is denoted by I. You will see that in algebra we always use I matrix for the actual name for the identity matrix, and that's where this actual name came from. So they try to make it as close as possible to what we are actually understanding of your numerical analysis, or from your algebra which you have done before, or sometimes called E, which is the first letter for I, and it behaves like a multiplicative identity for matrices, because it's important for you to actually use this especially when you are actually trying to calculate the inverse of a matrix. So it's actually rooted in the operations, mathematical operation. Okay, so the I, it has N for an M and K, and these data types are floats usually, and this is how it's actually utilized. So once we've finished with this explanation about the R, let's run this again and see how we actually create it. This is 4 by 4, and I said this will be 5 by 5, and so on. So you can create all these different identity matrix, and as I explained before, all these only the ones are actually in the middle of the array. So it's actually in location 0 in the first row, location 2 in the third row, location 4, location 5, and location they call it location row 0 and row 5. So but it's 1, 2, all 5 rows when we are talking about 5 rows, 5 by 5. Okay, now we can also see how we use the rand method or function within the random library. So we call the random function, and then we call the random function or method actually in this case, and I pass to that the value that I want to, the number of values that I wanted to create, and it will actually go and create these for me straight away, and it will create a one-dimensional array, and it will actually go and give me the numbers between 0 and 1. So can you see these numbers here? If I run it again, I should get some other different random numbers. Let's try it again just to reaffirm this case. So actually, can you see we've changed the numbers? If I run it again, it should give me, if I run this cell again, it should give me different numbers. Now I can use rand to create two-dimensional arrays. And here, can you see I just passed one to actually says 5, which actually tells me I wanted 5 components in this array. Now, if I wanted to make it two-dimensional, then I need to tell it how many dimension I want. So if I pass to this 1 and I run it, can you see it actually gave me this array is one-dimensional array, but it actually changed the way it's actually presented, which is useful for us. Now, if I want to change this into 2, then it will actually give me a two-dimensional array. And can you see now it's actually the first row of the array, the second row of the array, the third row, the fourth row, and the fifth row of the array, and each row has 2 values. So it's a 5 by 2. If I say it's 5 by 5, then it should give me 5 by 5, which is also useful, and it can be done, and then it becomes not a one-dimensional array, it becomes a two-dimensional array, which is actually here in this cell. So if I execute this cell, it should actually give me random content for this dimensional or two-dimensional array. And as I said, I can change these numbers and play with it to create any dimension that I require. So this is very important, as I explained earlier. Now this one I have showed you before, and let's talk about this one where actually I'm talking about the size and the value. And in this case, I'm using a method called random int, and it's actually because rand was creating for us random numbers between zeros and 1. But here I want to define the range of the random numbers. Before I didn't have to define, because that rand was actually just creating random numbers in the range that we provided with between 0 and 1. But now with the rand int, I can actually create random numbers bigger than 1, and I can specify the range between 1 and whatever range I want to actually create, and then I can pass the size of the actual array, how many actual specimen samples is actually going to be in the size of my one-dimensional array. So if I leave it as it is and run it, I have 8, 1, 9, 10, and 7. So it should give me some different values. It gave me 1, 10, 9, 8, and 5. If I run it again, it should give me some, the same cell I should be running. If I run it again, it give me different values between 1 and 11. Okay, so this is how this thing works, and I can change that to make it, let's say 7, and then it goes and create something with 7 components. Run it again. Oh, sorry, I actually go and run the cell below it. Okay, so it changed the numbers for me every time. Now, if I want to create, we saw how to create a two-dimensional. Let's create a three-dimensional array. To create a three-dimensional array using rand, which is the method which we have used before, then I actually tell it how it's actually going to create this for me. It's actually going to create 2 with the content, 2 arrays. This is, we can say this is one array, and this is another array. Okay, and I want them to be as one array. So it's 2 by 3. It's 1, 2, 3, 1, 2, 3. So that creates the first array, and then this creates the second array, and they are within one array, so they become one array. And I said I want each row to actually have 4 samples, and it has 4 samples, and I want it to be random, and that I used rand. That means the values are going to be between 0 and 1. and they're going to be different every time I run this code. So if I run it, can you see 0.549 in this case? If I run it again, it's 0.927, and all the other values have actually changed randomly. That doesn't mean that the numbers will not repeat, because randomness doesn't mean that it's 100% random, because we have some numbers that usually are repeated depending on the function. So there is also limits on randomness, because these functions, they never create anything called true randomness. That's why when you come to require true randomness, this becomes a problem. But it's as random as possible, let's say. Okay. By the way, randomness, you need to understand that there is no true randomness, or that's what I think. There is no true randomness from my experience. There is always order in chaos, i.e., whatever you think it's really a random, there is an order in that, and I have proved it many times in my life when I was actually working with random numbers. Okay, so we've seen how to create this three-dimensional, or let's say two-dimensional, or one-dimensional array using these functions and methods. So let's go to the next example, and here I want to generate one-dimensional array with 5 random numbers from a standard normal distribution. So I want a standard normal distribution, and what I do, there is the method rand, which we have used before, but now I want with normal distribution. So they've changed the name of the methods from rand to randn, which means now it will actually give me a random distribution of this array that we are actually creating. And for those of you who don't know what we mean by random distribution, then you need to go back and look at that in mathematics, look at it in statistics, and so you can understand what random distribution is and how we can actually utilize this. So if I run this, it actually gave me 1, 5, 8, 5, 0, 3, 3, 0, 2, 3, 4, and so on. If I run it again, just to see, sorry, I should be running this one here, then you see it actually changes the numbers and it gives me different numbers, but they are all normally distributed values. So it's very important that if we want to generate two-dimensional array with random distribution, then we pass the actual dimensionality that we want. So if I want to create a 3 by 4, then I just pass 3 by 4. I only passed one dimension here because it takes the 1 by default, and that's why it actually only created a one dimension, since I didn't supply the dimensionality. In this case, I actually on purpose have supplied the dimensionality, therefore it will actually create according to what we actually provide the function with, or the method with. So if I run this, then you will see that it actually two-dimensional array, and it's 3 rows by 4 samples. Okay, therefore we call this 3 by 4 array. So if I want to change this to make it 4 by 4, I will say 4 by 4, and if I run it, and it becomes 4 by 4. And if I want it to be 6 by 4, then I will create a 6 by 4. Or if I want 4 or 4 by 6, then I actually just have to change that, and it will change the dimensionality again for me. So as you can see, it's useful and is very helpful to understand that all these methods are available for us to actually create these functions. And again, if I want to create a function identity use the random function, and I want to utilize the result of that function to create some values, then it's simple enough for me. I have some logic here, and I want to calculate this logic, this mathematical function, and then multiply it by the output of that random distributed numbers that are actually coming, and then insert that into my array. Then this is what I will do. Whatever value is actually chosen randomly, it's multiplied by 2 plus 3. I can change, let me run this first, and I can say it's actually 5, and it should give me exactly, so it's 5 times that. But I wanted to show you that you can have a mathematical function there that you enter, or a mathematical function that you have defined yourself for the logic you are trying to achieve. Therefore, you can do that and you can utilize it. So if I run this again, you can see that it's actually the same. Now we can generate a 3D array with shape, and we can decide on this, and whatever we did with rand earlier, we can do with rand n here. So I am just repeating what we did earlier. So to see that there is no difference, it's just the way we create the random values are following a rule. In this case here, we are following the random distribution laws. Before it was just rand, which means random distribution between zeros and ones and so on. So I actually want to create a random array, which is a 3D. Then I can actually tell it what I want. I want 3 by 4, but I want 2 of them. So it's 2 followed by the dimension, which is 3 by 4. So I can change this to make it 4 by 4, or I can make it whatever I actually want in here, and it will change it to 4 by 8. Therefore, it's, or 8 by 4. Therefore, the result is very important for us to actually understand what we are doing. So let's run this and see what we get. We have 2 nested arrays. Each is 3 by 4. Okay, now I can change this and make it 4. So I will have 2 4 by 4. So if I run this, can you see I have the first nested array, which is 4 by 4, and I have the second nested array by 4 by 4, and they are all making one array, which is 8 by 4. So it's important to understand the logic here. We can generate a one-dimensional array with random integers between 1 and 10, and again I am actually using this random integer methods which I explained earlier, but I want to, instead of not saying what I want to add the actual step. Okay, and the size is 5 in this case, so it's between 1 and 11, and the size is actually 5. So I have 5 samples in my array, and it's actually random between these 2 values, not between 0 and 1, but I am actually specifying, and I'm saying I want them integers, because what did I have here? I had floats. Okay, and here I am actually saying I want them integers between this range. Okay, therefore if I run this, it should actually give me 95476. If I run it again, it should give me different values, 21793, and so on. So it actually works, and it's a nice way when you require something like this for some logic that you are trying to achieve. We can also use shape. So we can shape our arrays. We can change the shape from 1-dimensional to 2-dimensional to 3-dimensional and so on. Therefore, let's see what we can actually do in this function. And again, all I need to do is to call arrange, and I will tell it to give me an array. Once I have created the array itself, then I can actually use that array to call a function, and I can change the shape of the array. Now, in the first one, I have created a one-dimensional array, and this is actually contained for 13 samples. Okay, all it did, it just iterated over the actual sample from 1 to 13, and it just included the sample itself in the array. That's all it did in the first function. The second function, I am actually calling the reshape, and in here I am calling it array underscore 1. I am actually calling this array which was created, and I will call this function on this array. That's what I'm doing. I am using the array and I'm calling this function on the array. So that means I want to take the output of this creation, and I want to call this reshape on it, and I will give it the actual shape that I want. And I want to convert the array, the original array which was created, the one-dimensional array, I want to convert it into 3 by 4. Okay, that means I will have 3 rows and 4 samples per row. So if I can change this also if I want, but I need to understand the original size of the array, the one-dimensional array, before I can start, because we will look and practice and see how this actually will work. So let's run this and see it actually created the one-dimensional array. Then if I don't have this actually running, and I comment this and this, now if I run this, I just created the one-dimensional array. Now, since it's created, if I go and comment this and try it again, you can see I still have it because it's created previously and it's actually available here. Now, if I go and uncomment this and uncomment this and uncomment this, I should actually now bring the same results. But now I am not creating the array because I have already created it earlier in a previous run, and Jupyter Notebooks give me that ability. So it's important to understand this. This will simulate that you have already created an array in some earlier stage in your code, and then you are actually using this array to change the shape of that array, and this is how it's done, and I changed it to 3 by 4. So let's change this to 4 by 4. Now if I run this, it actually say you are unmatched. So that's what I said earlier. You need to understand the length of your array to be able to reshape it. Okay, so you need to reshape within the range of your array. So I actually have a mistake there. So I had the original array, but I couldn't reshape because they are different shapes. Okay, 4 by 4, and I cannot. It will give me the first row, the second row, the third row, but when it comes to the fourth row, it will not be able to have any values, and I didn't tell it what to put there. You can actually introduce some functionality to say that like a for loop, and to tell it that once you reach the maximum in your array, you enter zeros, and then you can solve this problem. But to actually use it directly like this, it's not going to work. Okay, and we have seen that. So this is how I've actually done it. Okay, now if I run this, I can remove the error that I have done, and I can actually remove this comment here to so you know where when you come to run this, it actually gives you the right result, because if I keep it commented, then it will not run when you come to download the Jupyter notebook, and you will not know what you have actually done. Now I am actually going to show you how we can actually use max, min, argmax, and argmin. And you know what max is and you know what min is, but argmax is actually when you want to take the maximum of two values, we use argmax, or three values or four values, whatever it is. Or an argmin is the same. You pass to it some values and it will give you the minimum of these values. So these functions are very, very important functions in our machine learning course, and we will use them many times, and it's useful to actually see how they are used and utilized. So in this cell, what I'm doing, I'm creating a one-dimensional array, and then I want to find the maximum and the minimum value of these. So I'm going to use the two functions at the beginning here, and what I will do, I will actually create initially this array, and then I will actually then okay, and let me explain here that I have actually passed the array a list that is created manually. I can create it with any of the methods that we have seen earlier. So this means that I already have a list which I want to work on, a list that contains some data that I want to work on, and then I can actually use it to find the minimum or the maximum within that list I am working on, because we will actually see this a lot when we are working with machine learning development. So the first row here will create the array, and then the second is actually calling the max function, and I pass to it the array which we created earlier, and then the next line I want to find out what the minimum. I call the minimum function from NumPy, and I pass to it the array again, and it should return for us in both cases 9 and 1, because the minimum is 1 and the maximum is 9. So if I run this, as you can see, it's actually done. Let's change this into 15, and now run. It actually changed. It found the maximum and the minimum. Let's make this one into a 0, and if I run this, it actually comes back with different. So whatever you add in your list here, it should actually go and give you the maximum and the minimum, and it's a very useful functions that we use. Now I want to find the arg max and arg min, and if I have it will actually gives you find the indices of the maximum and the minimum value. Argmax will give me the indices of the maximum value and the indices of the minimum value. So let's run this and see. It will actually go and give me where is the minimum value located. It's actually located in index 0. And where is the maximum value? It's actually located in index 2, because it's 0, 1, and 2, and that's the maximum. Now if I make this into 25, for example, and run this again, now these indices should actually change, and now it gives me actually location 4, because 0, 1, 2, 3, and 4. 0, 1, 2, 3, and 4. So that's 25 the maximum, and 0 is the minimum. And if I change this into 0 anywhere else, then it should actually give me that. Now we can do this for two-dimensional arrays. Again, I create the two-dimensional array, and the max function, what it will do, it will just iterate through these. It will iterate through the values of the first row. It will iterate then after that the values of the second row, the third row, and it will return whichever, because it will be comparing and storing whenever it finds the max, it actually stores that as the temporary max. Then if it finds the second max, a higher value, it will actually store that into the temporary variable until it reached the end iterate. So it iterated through all the values. Then it will actually say this was the max, and it will do the same for the min and so on. So we can show that it actually works, and it actually original array is there, and the highest value is 9 and the lowest value is 1. So it iterated through these rows until it reaches the end. Now the argmax will do exactly the same. It will iterate, find out where is the maximum, but now it's iterating through indices, and it will say that the minimum is at 0 and the maximum is at 8, because it actually goes through them row by row, index by index, and it actually then give me, and it will keep incrementing the indices. This is indices 0, and that's indices 8, because 0 to 8 is 9. So if we run this, it actually gives us the values as it is. Now I want to reshape arrays. So I have created an array, a one-dimensional array using a list, and then I can reshape that in any way I want. So if I want to reshape it, get the shape of the array, then I just say I want the shape. So and to do that, I will just call shape, and that method there by itself, it will read the array created, and it will see that it's only one row. Therefore, it will say it's one dimension. If I have another row, then it will say it's a 2-dimension. If I have 3 rows, then it will say it's a 3-dimension. Sorry, it will give me the dimension, the number of samples by the rows by the number of samples to give me the dimension that is required. So if I run this, it says it's actually one-dimensional array, and it contains 5. Okay, it didn't say what else it actually contained, because it will actually give you that later on in another example. Now if I want to convert a one-dimensional array which contains tuples into an array that has 5 along only one dimension, then it's possible to do that. And if I have this, then I can run this. Okay, what do I have? I have 2 which is a nested list, okay, which I am passing to this array function, and it will convert this into an array of 2 by 3. Okay, then I will pass the created array, which is this here, into my shape. So I am actually calling shape on this array by saying array or arr underscore second, which is the name of the variable where I store this 2-dimensional array. I will call shape on that. Then this will iterate through it, and it will go index 0 on the first row to the maximum index. Then it will go and change rows. So it's like iterating through a for loop, and it's incrementing the number of both rows, and then within the rows you are actually iterating through the row index itself. Okay, so it's a nested for loop. You can actually do exactly the same thing here, and it should give you the shape in this case, and it should say that the shape in this case should be a 2-dimensional array, because this is what it's going to be. So it actually gave me the shape, which is 2 by 3, because it actually counted the indices in each row, and it actually counted the number of rows. Now if I change this and increase, then it should actually change the result. Let's say I actually go and include another list here. Okay, and then if I run this, now it actually gives me a different array, and it says it's a 3 by 3. Okay, so you can actually convert any array that you have. You can find the length of that array or the dimension of that array if you like. So reshape. Reshape also is something we have seen in one-dimensional array, and we can actually do it in a different manner. And in this case, we are actually passing the reshape. We say 1, and we are actually going to go from -1 in this case, where I am actually passing -1 rather than actually saying 1. I want to convert it into a two-dimensional array. Let's see how we do that. If I run this, it's actually reshape two-dimensional array. How did I reshape two-dimensional? You take because what did we create? We create array reshaped, and this array reshaped took this array which we have created earlier, which is here, array 1 underscore 1 dimension, which is created, I think, here. Okay, we are calling this array here, and then from there we are actually creating a two-dimension. But because this actually only have one dimension, it actually gives it as in such. Can you see? Because if it had more values, what happens? It will actually go and put them in space followed by the other row. So if I change this, and I will actually call the array reshape, if I pass to that the second dimensional array, so if I say 2, and if I run this, now what did I do? I converted a two-dimensional array or a three-dimensional array to it's actually 3 by 3. I converted to a one-dimensional array. So reshape is very powerful and very easy. So we have an array that we have created earlier, then we can actually reshape that from whatever shape it's in to a one-dimensional array, which is a vector. When we are using mathematics, we call that a vector also. Now, the D-type attributes in NumPy stand for data type, and in most cases, when you are programming, you will see that you will have problems when you are defining something and you are trying to calculate something, but it's actually in a different data type. Therefore, it will be useful for you to actually understand what the data type, and maybe to convert some data from one type to another type and so on. And this is very important. So the data type attribute in NumPy stands for data type, and it's used to retrieve the data type of the elements in NumPy array. Knowing the data is important to ensuring that operations are performed correctly and efficiently. As I said, you will actually try to execute some operation, and you think that the data you are using is suitable for this operation because you assume it's in a certain data type, or you have a data set, and this data set contains millions of lines of data, and in that data set sometimes there is the wrong data shape that is actually entered, okay, the wrong data type. Therefore, when you come to use this data, you will end up with an error because you have one of the items in that data which is actually in the wrong data type. Therefore, it will create an error. Therefore, it's always nice to check the data type and to understand what you are playing with, what you are working with. So let's see how we actually use that. So if I have this array, this list which I want to pass and create an array to this function array, and as you can see here, I have integers, I have float, I have boolean, and I have string. Okay, so if I create this, it should give me an array which contain all these different types. Now, if I want to find the data type, it should actually tell me that it's a data type, a universal data type. It actually contains all sorts of data. Okay, or if I have all integers, it will come back and say they are type integer, or if they are float, it will come back and it will tell me it's a float 32 or 64, whatever we are using. So let's run this and see if it actually works. And it actually created the array, which actually can you see it contains 1, 2.5, hello, and true, and there is no commas between them. And because they are different data types, what it's done is actually inserted single quote, and within the single quote inserted the actual samples for the index. And then we passed this by calling the array. We call the data type function on that, and it actually goes and return, and it says data type of the array is uni32, which means it's universal data. It contains all the different types of data. Okay, so in this case, the use of the data attribute is helpful when you want to explicitly specify a check that data type of the element in your array is of certain data or not before you carry out the array. And if it's not, then you go and convert that to the data type that you want before you start the next operation. So it's always useful to know what you are working with. Okay, so in this second example, I have actually passed a list which contains integers, but I want to actually say in the data type float. I want it to be specified in the data type float, and I will explain that in a second for you. So when I create the array from this list, and let's do it without this float first. Okay, now if I create this, you can see that it actually just gave me integer 32, the shape, because I didn't specify what the type is going to be. And notice I have 1, 2, and 3. Now let me bring this back. Okay, and if I run this again, then I should receive something else. It says, but I still have 1, 2, 3, and the data type is changed to float 64. How do I know it's float or not? Can you see I have a dot after the 1? Before I didn't have a dot after the 1 because I could have some decimals there to make it into a float number. So what I've done, I converted the integers into float, and this function has actually just added a dot, and it says it could be dot da 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 da, whatever it is that I want to be actually added there. So this actually complete the first Jupyter notebook on this NumPy. I will stop the video here, and I will come back in the next video with a second Jupyter notebook. We will go and look further into the use and how we can manipulate NumPy arrays.